The kernel of the mixer is a new FPGA engine which is capable of not just 64 into 32 mixes. This engine's hundreds of inputs into 64 mixes, and this implementation is 128 into 64 mixes, all at 96k sampling. That represents a ×4 on audio signal processing requirement. Couple that with the enhanced processing requirements for filtering, for more enhanced compressors and dynamic EQ on channels in the future, that really adds up to a ×8 power factor on what iLive's capable of, and that required a lot of innovative work in FPGA to provide that platform. You can't do this with traditional DSP. We've ported the iLive algorithms and also provided more facilities to develop much more powerful algorithms in the FPGA. To do that, we had to develop DSP kernels in FPGA that were capable of running those algorithms. So they really appear as mini DSPs, but much more powerful. We had to also study the bit widths and the bit widths and the way we wrote algorithms on DSP and try and reproduce that in FPGA. And in fact, we've ended up with much wider bit performance where it matters on FPGA than we even had in DSP.
Well, one of the main limitations on the DSP side was that with the high level of I/O, the 128 inputs, the I/O on the actual DSP chip just wasn't there for a start, and that's not even taking into account going to 96k. You've obviously got a fixed number of cycles in your DSP, so you need twice as many of them, and loads of consequential problems from that. So to move into the FPGA was kind of the obvious choice, I suppose. To get the mixer going was brilliant, and then we thought, right, how can we go from use this kind of methodology to generate something that would do all the audio processing, implement the same kind of algorithms we wanted to maintain from the iLive and the GLD. To
get the sonic performance right and the way the controls change and filter types change, it's very important to look at bit widths in all parts of the algorithms. And we've done that with FPGA. We've taken the same knowledge that we had on iLive, implemented on DSP, into the FPGA domain.